Hi, I'm back with another video about sequences and series as part of the quiz bee I held a few months ago. So this question now asks for the sum of this expression here from n equals 0 to infinity. This looks kind of long. I mean, the summands are kind of complicated, but it's actually quite easy if you look more into it. Note that if you look at the terms, we can split the sum into two after the by splitting around the plus sign. So we have here the first one as the sum of 1/4 raised to n plus 2 plus the sum of from 0 to infinity of 3 to the 2n times 10 to the 3 minus n. Both of them somehow takes the form that is quite similar to the geometric series that takes the form x to the n. Now remember that for x less than 1, or the absolute value of x less than 1, we have the sum of this infinite series as 1 over 1 minus x. We can also look at an alternative form of the series if you're not comfortable with this one, in the form that looks like a sub 0 plus a sub 1 times r plus a sub 2 times r squared plus and so on, where the common ratio here is r. For the first one, the common ratio is x. The second one, the common ratio is r. Now this second expression is equivalent to a sub 0 over 1 minus r for r less than 1 as well. So these two forms will be quite useful when we evaluate the sum that we want. So let's duplicate this page and then do some modifications. Now, if you look at the first expression, the summand is 1/4 raised to n plus 2. So in this one, the common ratio is always the base term, or the base of the exponent, as I've mentioned here. So in this case, that would be x. So for the case of the of the first expression, that would be 1/4. So the r here is equal to 1/4. The first term here can be obtained by letting n be 0. So the first term here is 1/4 raised to 0 plus 2, or 1 over 4 squared, or 1 over 16. Therefore, the first expression is equivalent to a sub 0 over 1 minus r, which is 1 over 16, over 1 minus 1/4. That's 1 over 16 over 3/4, and that's equal to, I'll cancel the 4 here, that should give me 1 over 12. Therefore, the first part is equal to 1 over 12. Okay, again, what I did here is to just find the first term of the sequence, that's a sub 0, and then find the common difference, and so on. Okay, that's the same method that I will use for the second expression, or the second sum. So in this one, we can write we can write 10 to the 3 minus n as 10 cubed over 10 over n. Yes? And then we can factor out the 10 cubed so that we'll get 10 cubed times the sum of 3 to the 2n over 10 to the n. To find the common ratio, we have to isolate the n in the exponent. So this will look like the sum of 3 squared over 10 to the n from n equals 0 to infinity. We can simplify the 3 squared over 10 as 9 over 10. Therefore, the r here is 9 over 10. That's a common ratio, the base of the exponent. The first term is the value at n equals 0, and at n equals 0, 9 to the 10 to the 0 is 1 times the coefficient that is 10 cubed, So a sub 0 is 10 cubed. Again, the formula that we will use is a sub 0 over 1 minus r. So that's 10 cubed over 1 minus 9 over 10. That's 10 cubed over 1 over 10, or 10 to the fourth. Therefore, the second part is 10 to the fourth. So if we go back to the original expression, this thing here is 1 over 12. This thing here is equal to 10 to the fourth. Therefore, what we want is 10 to the fourth plus 1 over 12. We can write that as a mixed fraction. That's 1, 2, 3, 4, and 1 over 12. This should be okay. But if you want to make it a mixed number, then you rewrite that and it becomes 12001 over 12. Both answers should be accepted and are fine. Okay? So whenever you see problems or sums that look like this, where you have some base number raised to an exponent, where the exponent is in terms of n, that's likely going to be a geometric series. By the way, I forgot to emphasize earlier that it is worth checking first that the common ratio is indeed less than 1. So in this case, the second expression, it's 9 over 10, that's less than 1. For the first expression, r equals 1/4, which is also less than 1. So both of them are less than 1, so we can definitely use the formula that is a sub 0 over 1 minus r. Otherwise, we cannot use a formula and we say that the series diverges. Okay? So this is an important, classic problem, a classic concept that you should be familiar with if you aim to join high school and collegiate math contests. Okay? Hope you learned something from me today. Thank you for watching and see you on the next one. Bye-bye.